We welcome you back to the educational webinar series brought to you by WeatherWorks. My name is Nathan Wiles, lead meteorologist and assistant marketing director of the company. Today we will be expanding your knowledge of weather by breaking down some important weather terms and examining a few common misconceptions. Our presenter today is WeatherWorks' own Director of Communications, Mike Mihalik. Mike has been with the company for over 12 years and has served not only as one of our senior meteorologists, but he continues to lead the social media department and now assists in managing the Certified Snowfall Totals product. Mike, the floor is yours.
Hey, thanks a lot, Nate, for the introduction. I really appreciate all the nice accolades there for myself. But yeah, my name's Mike Mihalik. We're going to go over a lot of weather misconceptions here that show up in forecast, or maybe just some weather knowledge situations where you might not be sure what's going on. So real quick, webinar goals are uncovering the truth behind percentage of precipitation, or POP. We're going to examine some misleading radars, and we're also going to look into some common misconceptions that we might have with the weather. And again, I'm a senior meteorologist here at WeatherWorks. I'm director of communications. I've been here since 2008, so I have a few years under my belt. But I also manage all the publications here at WeatherWorks and the social media department, and I'm a Penn State graduate, so go State if anybody's a Penn Stater out there. But let's get right into the webinar here, and we're going to start out with some forecast language things. So a lot of times you'll see these things in your forecast, and you might not be exactly sure what it means. And the first thing we're going to talk about is that percentage of precipitation. What does that 40% chance of precipitation mean? Does it mean we're 40% confident? Does it mean that there's a 40% chance during a given time something's going to happen, or 40% of the area is actually going to see some rain or snow? So if we break that down right now, the probability of precipitation right there on the screen in red describes the chance of precipitation occurring at any point in a given area. So now this isn't just some arbitrary number that we come up with, okay, guys? This is something that we have a little bit of a formula for. So let's check out that formula. So this is what POP actually is in your forecast. It's the percent confidence times the aerial coverage of precipitation. So let's think about that a little bit. So in the first example you do see on the screen there, so a forecaster could be, or myself, could be 100% confident that snow will occur in only 40% of the area. So if we use that formula and we do the percentages, 100% times 40% equals 40%. But it could be a little bit different too. In the second example, I can only be maybe 50% confident of snow occurring. And maybe I think it'll cover 80% of the area. So if you do that math, that's also 40%. So that's kind of how we break it down a little bit. So it really depends on what my confidence is that snow will actually get there, and what I think the coverage is going to be. So think of a snow shower day. I might be 100% confident that there's going to be snow falling from the clouds into your region. But you know what? Might only be 20% of your region that actually sees that snow shower. So that means you're only looking at a 20% chance, which is quite minimal, to actually see that snow falling from the sky. So that's what we're looking at with that percentage of precipitation, or POP. Moving on here, so the forecast language with these POP values can change a little bit. So we just want to go over what it actually means when we say 10 to 25%. So a 10 to 25% range is usually a very low confidence forecast. You're looking at isolated coverage, and you're also looking at a descriptor in our forecast that might say it's not ruled out for a flurry, or there's a slight chance of a snow shower. That's usually that very low percentage. Moving up to moderate, now that's when we start getting into the scattered category. We like to call them scattered showers or scattered snow showers, something to that effect. And that's in that 30 to 55% range. Now that's usually a chance wording too. You might see a chance of showers. So if it falls in that range of POP, that's kind of where we're leaning. as far as the percentages. Now, high percentage, high confidence events, we're looking at over 60% to about 75%, and that's when we use that likely wording. So you might see a period of rain likely, or a period of snow likely, or snow showers likely. So we're very confident that we're going to see that precipitation and that it will be quite numerous. Say if it's a shower, and we're going to look at more numerous showers than just those scattered or isolated events. And then once we get into the very high range from the 80 to 100%, usually we might not even use any type of likely wording. We just might say periods of rain through the day, or we might just say rain, period. That's it. Because most of the day is going to rain for almost all of the region. So that's something to think about when you are reading those forecasts, what exactly those words mean, the likely, the chances, the isolated. So hopefully that clarifies that just a little bit. Now, moving along off of pop, we're going to go into the sky conditions, because a lot of times you'll see sunny, you'll see clear, you'll see mostly sunny, partly sunny, mostly cloudy, whatever it might mean. But actually, these wordings equate to fractions of sky cover, and they're done by eighths. So when it's clear or sunny, you're going to have about 1/8 of the sky or less seeing actual cloud cover in the sky. So pretty much you're looking at full sun for the day, maybe a cloud or two, not much more. Moving up to mostly sunny or mostly clear, it's about 1/8 to 3/8 of the sky. So still a lot of sunshine, a lot of clear skies. Partly cloudy, partly sunny. Okay, so partly cloudy and partly sunny are essentially the same. There's not really a difference here. You just use partly cloudy at night and you use partly sunny during the day, because you can't say partly moony or anything like that at night. It just doesn't work out. So partly cloudy at night, partly sunny in the day, 3/8 to 5/8 sky cover. Mostly cloudy, we're starting to get into those higher percentages. Over 50% of the sky is certainly covered with clouds. And then once you get to cloudy, you're talking about an overcast day where there's clouds from one horizon to the next horizon. So that's basically it for that. So moving along, we covered the clouds. So I think the next thing we're going to look at is radar. I know a lot of you out there have used radar in the past. So basically what radar means, it actually stands for radio detection and ranging. So how it works, it's quite interesting. So the radar dome, or the dish, actually sends out a radio signal. It hits a particle in the sky. In this case, we're talking about raindrops, snow, hail, sleet, whatever it might be. And then it sends that pulse back to the radar, and then it records it. So it's seeing that particle, it's hitting that particle, reflecting back to the radar. So that's how it's actually working. And it's quite interesting, how this all works out. And I know you guys use it a lot. And I just want you to make sure that with radar, it's actually oriented at an angle off the ground. The radar dome itself is actually 40 feet off the ground. So we're already starting at a higher position. So you're not actually seeing the rain or precipitation at the ground level. What you're actually seeing is what's happening maybe a couple hundred, a couple thousand feet up, and it gets higher the farther away from the actual radar site. So you got to understand that it's not seeing that ground level precipitation. It's actually shooting higher up into the cloud, and that's what it's actually showing. So hopefully that kind of clears that up a little bit, and that'll lead into something we'll talk about a little bit later called VIRGA, and that's an important thing to remember when we're talking about radar and VIRGA. But before we get into that, I really want to talk about precipitation types. So a really cool thing happened to radar probably about in 2012, 2013. It was something called dual polarization. So what this does, it actually sends out different radar beams oriented horizontally and also vertically. So it sends us out kind of like that. So what this allows with our radar is to not only see that particle out there, but actually gives us the size of the particle, which is very important when we're talking about precipitation types. And that's what we're going to talk about right now. So as you can see on the radar, The one side here, I don't know if you can see here my cursor, but if you're looking at the Chicago radar with a lot of the pinks there, you're seeing a snow, a mix, and to rain. So that mix line is going kind of right through Chicago there, and that is showing, in those yellow colors. And that's showing particles of different size. They're not uniform size. So there's some sort of rain mixed with snow, mixed with sleet going on in that band. So that's why we know that's the rain snow line now, and that's why dual pole is so great with the new radars that we have now. And that usually shows up on regular radar as some brighter echoes too, something that is showing up in these yellows and these reds and oranges. That's usually something like sleet. If a yellow condition is snow, we're talking about some really seriously heavy snow going on with that. So that's sleet or mixed precip shown on the radar. So that's something you want to be looking for, or you can just always give us a call here at WeatherWorks, because our meteorologists are always looking at the weather. And if you have our storm alert service, that's what we'll do for you. We'll pick out that rain and snow line. So moving on. So here's the range of which the radar shows, basically showing the intensity scale. So you can see starting out way down here, it's called the dBz is how they measure the returns coming back to the radar. That'll go higher the more density of particles you do have in the air. So at 5 dBz, you're not looking at a lot, just like light drizzle, trace, sprinkles, that goes all the way up. Once you hit into the 30 dBz or higher, you're getting into some pretty moderate rainfall or pretty heavy snowfall. And then once you're into the reds, the oranges, even some of these pinks, that's talking about some intense thunderstorm, possibly hail with those thunderstorms. So here's a nice graphic for you guys. So if you ever forget what that could be, you can always reference this webinar and take a screenshot of this and say, oh, okay, now I kind of understand what's going on and what is intense and what is not when I'm looking at the radar. Now, what I talked about earlier was VIRGA. So VIRGA is quite interesting because it's very deceiving. And this is where we start getting into some of the weather misconceptions here. So what happens in a VIRGA situation is that a lot of times the radar will show green or blue or whatever it's doing over your region, and you might go outside and it's not even snowing. So you're thinking to yourself, what's going on? I mean, why isn't it snowing? I think the big thing we have to think about here is, remember that radar beam shooting out at a very high elevation as you get further away from the radar. So when that happens, you're shooting higher up in the atmosphere. So if there's a lot of dry air underneath that radar beam closer to the ground surface, that's when you can have the snow falling from the sky, running into that dry air and evaporating before it reaches the ground. So that's what VIRGA is. The snow or rain is falling out of the cloud. Radar sees it, but it's just evaporating with that dry air and it's not actually reaching. So while it looks like you're like, oh, it's going to snow any second, it really might not be. So let's take a look at a little example here. So this is example from 11 to 12 at night. And I want you to kind of key in on this white dot here on the weather radar on the left. So in this situation, you can see that, okay, it looks like it's snowing all the way through northern New Jersey, in through New York City by the time we get towards midnight here. But in actuality, we confirm this using the observations here. So if you look on the right-hand side, these are the weather observations from various airports, and it's showing that the snow line is only through Allentown in eastern Pennsylvania. It's getting through Trenton in New Jersey here, and it's not even gotten to Belmar on the New Jersey shore. And you can see that it is not snowing at all once you get into Newark, New York City, and those areas in northern New Jersey. So that's why it's deceiving. That's why we have to look at this as forecasters and say, okay, where is the snow actually falling? Because the radar isn't quite telling me the ground truth right now. And that's how we have to kind of pinpoint where exactly that snow line is moving from. So something to keep in mind, always double check for ground truth if you're looking at radar and nothing's falling overhead. So moving along, let's look into some weather misconceptions. So a lot of times I hear people say that it's too cold to snow or it's too warm to snow. So too warm is a little bit easier to explain, but too cold to snow, I have a little problems with that. I kind of think that's a little bit false because I've seen snow fall, especially in New England, when it's about 7, 8, 9 degrees and there's still a lot of snow falling. So it can occur. So I don't want you to ever think that it's too cold to snow. The reason people think it's too cold to snow is because of high pressure. Usually when it's too cold to snow, there's a big high pressure over the area is what they're thinking, and that's usually very dry. So when it's very cold and very dry, it's usually hard to get precipitation to fall through that atmosphere. So that's why people may say it's too cold to snow. But if there's a system moving into that, like a nor'easter or something like that, again, I've seen it snow at 8 or 9 degrees. But typically when it is that cold, the snow, it becomes more needle-like. It's not the nice big flakes that you may see that are like the big fat flakes that fall down and accumulate on everything very quickly. It's more like a dust or a needle type flake, which is a very low accumulation rate that usually comes out of that. So that is what's going on at very low degrees. You're getting that very fine snow. It doesn't accumulate that rapidly. So when it's too cold too warm to snow, now that is a little bit easier to understand because at 41 degrees, that is about the temperature at the ground surface where it's hard to get a snowflake all the way down without melting from the cloud. So that's usually where the mark is. Now, depending on how heavy that snow comes in, that could, waver one way or another. But 41 degrees is a good kind of estimate. But the exception would be something called Graupel. Now, Graupel can fall all the way to the ground at 45 degrees because Graupel is actually almost like a snowflake covered in ice. So it doesn't melt as quickly as a snowflake was. Think of a snowflake, it's very fluffy, so it melts very easy when it falls down. So we'll talk about Graupel here in a little bit later, but that's generally the too cold, too warm to snow. Moving on to weather misconceptions about snow can't stick to the pavement when the air temperature is above freezing. So this is one that I struggle with a lot because a lot of people in the early season or late in the winter towards March, April, they may think that just because it's early or late in the season, the snow's not going to stick. It's going to melt on the pavement, and I'm not going to have an issue with that. But that's just not true. And I'll tell you why here right in the next thing. So obviously we're going to call this false. So think about this. If we've had several days that are below freezing, okay, that's going to give pavement temperatures that are below freezing also. So even if you're snowing at 35 degrees and those pavement temperatures are cold, like 29 degrees, that snow is going to stick, especially if that snow is coming later in the day and into the night. So we got to watch those pavement temperatures carefully when that snow is falling. Also, shaded surfaces will easily stick too because they're not just getting all that sunlight. It doesn't have those direct rays, doesn't have all that going on. So the shaded surfaces are colder, they can also stick too. Heavy bands of snow is my biggest thing. Look, if it's going to snow 1 to 2 inches an hour or more, I don't care if it was 70, 80 degrees the day prior. Okay. Basically what happens is that snow, as it's hitting the pavement, cannot melt fast enough for the rate of the snow that's falling. So even though it's trying to melt, if you just keep dumping snowflakes on that, eventually it's going to form that slush and it's going to start sticking on top of that. So that's something to really key on is the snowfall rate. We're talking over an inch an hour. You're probably going to stick on pavements. It might melt back as soon as the snow lightens up, but that's what we're looking at. And the last thing is sleet. So sleet is those little balls of ice. We'll talk about that soon. That can form a nice layer of ice on the ground. Not a layer as in like an ice skating rink, but just those little balls of ice, like little ball bearings. So when that gets on the ground, it provides a surface for the snow to stick to. So sleet is a good primer for getting that snow to stick on the pavements, so even if they're warm. So sleet versus freezing rain. So this is one that gets mixed up, and I understand why. Because sleet is those little balls of ice. It looks like BBs of ice. If you had a BB gun as a kid, I'm sure you know what I'm talking about. So freezing rain kind of sounds like the same thing. Okay, there's a raindrop that's frozen and it's hitting the ground. But really, when we're talking about freezing rain, we're talking about liquid rain that's falling, and well, rain's always liquid, obviously. But we're talking about rain that's falling, and then it's hitting a cold surface that's freezing or below. And as soon as that hits the surface, it freezes into a sheet of ice. It cakes to signs, power lines, trees, creates tree damage, power outages, all kinds of problems. And the roads are just terrible and need salted tons of times. But so that's what we have going on with freezing rain. So freezing rain is rain, but it actually freezes to everything, creating that sheet of ice. Sleet is those sleet pellets that come down, and they're like frozen water drops that form those little BBs and make a lot of noise when they hit. They bounce all over the place, that sort of thing. It's a real pain to try to plow it. I know I used to be a snowplow contractor, so I know what they're talking about and what you guys deal with sometimes for those out there listening to this. So that's sleet and freezing rain. Now, to throw another wrinkle into this, we have sleet, we have freezing rain, but now we're going to talk about sleet, hail, and graupel, all basically chunks of ice that fall from the sky, but they fall for different reasons. So let's start with sleet. On the right there, sleet is liquid precipitation that freezes into that BB type shape and then hits the ground. This happens in winter, okay? So we get those little BBs of sleet, no more than a couple of millimeters. Now, hail forms by a different process. Hail is raindrops that get driven up into the clouds, say in a thunderstorm, which they usually fall out of, by an updraft. So thunderstorms have updrafts and downdrafts. The raindrops get taken up on the updraft, they freeze, they get pulled down on the downdraft, then they get caught by the updraft again after getting some more rain on them and go up into the cloud and freeze again. And this process occurs until the hailstone gets heavy enough to overcome that updraft, and then it falls. And if you cut a hailstone or if you cut a hailstone in half, you'd see that it has little rings for every time it went up into the cloud and down. Quite interesting. So that's in the summer in a thunderstorm. Now, graupel, that usually happens maybe in snow squalls, something like that. And what happens is snowflakes fall from the cloud. They run into a super cooled water droplet layer, and they get rimed in ice, and then they fall down. They kind of look like dipping dots, a lot of people say, dipping dots. So they're like soft. So if you pick them up, it'll kind of squish when you pick them up. So that's the difference between sleet, hail, and graupel. All right, so lightning can't strike the same place twice. That's false, okay? This is why. A lot of times, multiple strikes can occur along the same path. So the lightning comes down, it might flash 3 or 4 times before it's done with that lightning bolt. So that's something interesting. You'll see some high-speed videos or slow-mo videos out there of that occurring. You can look that up on YouTube. But the other thing that can occur is something like the Empire State Building is very tall. Now that's standing out amongst everything else. It's very tall. It has a thin needle on the top. So the lightning is going to want to strike that place more than once. Right there in our graphic here, it says 23 times a year on average, the Empire State Building gets struck by lightning. So that's something to really keep in mind, that lightning can strike the same place twice. It's not only a once in a lifetime thing, even though it's about 1,000,000 to 1 of you getting actually struck by a lightning bolt. So red sky at night, sailor's delight. So let's look at this one. You heard this saying, red sky at night, sailor's delight, red sky in the morning, sailor's warning. And that's how it goes. So basically what's happening is that sunset or sunrise, red or orange light is usually because longer wavelengths pass through a greater length of the atmosphere, which creates that red and orange light. And it's also scattered by some dirt or dust or something like that in the atmosphere. So that's what's going on to make that orange or red. Now, in where we live, a lot of times when a storm comes through, the backside of that is high pressure. And high pressure usually contains more of this dust and dirt and aerosols that come in from the western areas of the United States. So that's why it looks red after the storm passes, because you have that, more dirt and dust in the air from the high pressure system. So that's why it's red sky at night, sailor's delight. Red sky in the morning, sailor's warning is different because we're talking about mid to high altitude clouds that are coming in ahead of a storm system. So that may bring those orange or red hues to the morning sky. And if we have those high level clouds, sometimes a storm system is coming behind it with lower and lower clouds and then precipitation. So that's where they get that. But it doesn't always work out because storms don't always work from west to east. Sometimes they work from south to north, or sometimes you might get the high clouds and the storm misses. So not quite the foolproof rule of thumb, put it that way. Hilltops are colder than valleys. This is false. While the temperature usually goes down as you go higher up in elevation and higher up into the atmosphere, this doesn't always happen when you have a radiational cooling night. That's when it's clear and calm at night. And what happens there is that the ground radiates that warmth into the air, and the cool air settles down in those lower valley locations. So a lot of times the higher elevation might be a little warmer than the lower elevation on those clear, calm nights. So that is a little bit of a weather misconception. And going into polar vortex. Okay, so this one has been kind of ramped up by the media a little bit, probably back in 2014-15, when a big cold air outbreak came into the United States, and they said the polar vortex is striking. So let's get this straight. The polar vortex doesn't strike. It doesn't do that at all. So it's just basically cold air. The result of it is cold air moving in to the United States. It's not striking anything and causing damage or anything like that. So it's just basically a cold air outbreak. So the polar vortex is a wintertime phenomena. Well, that's false, because the polar vortex is always there. It's on the north and the south poles. It's always in the upper atmosphere, sitting there and spinning. It locks up that cold air around the poles. So why it's important in the summertime is that it's always locked up near the poles. It doesn't really break loose. But in the wintertime, it's different. In the wintertime, this vortex can get disrupted. And when that does, a piece of it can break into the United States and bring that cold air to the area. So that's why it's important. So the thing to remember here with the polar vortex is that it's not something new. I mean, it's been discovered since the 1950s, so we've known about it. And the other thing is that it's something we really need to watch more so in the winter, okay? Because in the winter, it can bring that cold air. In the winter 1920, the polar vortex basically stayed locked up around the poles, which is why we had much of a warm winter. So that's why it's very important to watch. And guys, that's about it. I don't think there's any other misconceptions that we missed here. If there is, you can certainly ask some questions, give us an email, that's for sure. My email is Mike Mihalik at WeatherWorksInc.com. You can certainly email me any questions if you'd like. There's our address right there. You know where to find us in Hackettstown, New Jersey. We're also at WeatherWorksInc.com. And also visit on social media. We have a lot of cool things there for you guys to see. We talk about different weather terms and things. We also have past webinars that you can see on YouTube. So if you missed one from before, you can certainly revisit those. And don't forget, we also have a podcast. So if you're in the car driving to work, you could certainly listen to the weather and how it affects different industries with myself and meteorologist Brad Miller. So that's about it, guys, and I hope you enjoyed the presentation. And again, if you have any questions, certainly give me an email.